Okay, so yesterday, everybody's with me? Yesterday we learned how to multiply and divide these rational expressions. Okay, rational expressions is basically just a fraction, okay, that includes like letters and numbers and addition and subtraction and all that kind of stuff. Okay, so what we're going to do today is we're going to do addition and subtraction of rational expressions. So let's do a real simple one. This is the easiest one. And I'm going to do a real general one before we do a specific problem. If I asked you to add these up, this is about the easiest addition you could do. You know, like Mr. Hamrick, they're all letters. How in the world can I add that up? But you can show how to add them up. So why is this the easy one? Somebody talk to me. Why is this the easiest addition problem with fractions? Because there's already a common denominator there, okay? It already has a common denominator. So what you're going to do is you're just going to put everything over that one common denominator, b. Once you do that, once you find your common denominator, in this case they give it to you, what do you have to do to the top now? You just keep the denominator the same, and what do you do to the top? Nobody? Just add them up. Just add them up. That's all you got to do. The same thing with subtraction, okay? If it was subtraction, it'd be the same thing. So that's how you would add fractions with a common denominator. So let's do an example. So these are fairly simple when they give you a common denominator. Are they always going to give you a common denominator? No. Of course not. You know how it works. All right. By the way, this is example 4A. All right. And then plus, make sure you write this down. X plus 3. 2x plus 5. All right. Takes me longer to write down the problem than it is to actually solve the problem, wouldn't you think? You're adding fractions. First thing you do is you look at the denominators. Well, thank goodness we have a common denominator. So what do we do with that denominator? You just rewrite it. You don't add them together, okay? You don't add them together. You just keep the denominator the same, all right? You just write it as one denominator. Now what you can do is you can add the top. So let's just do this in our head. Okay, so we add all the stuff on the top here. 2x squared. Is there anything up here to add with the 2x squared? No, so we just go 2x squared. Now we have a negative 4. Are there any other regular numbers? Sure. Negative 4 plus, let's do the x first, okay? Let's do that. It really doesn't matter, but I'm going to put the plus x, right? So I'm done with the 2x squared. I'm done with the x. Now I've got negative 4 plus 3 is negative 1. You leave it like that. That's all there is to it. Man, that'd be nice if the whole test was like that, wouldn't it? Yeah, well, you know how it goes. It's not going to be like that. Right, this won't factor anyway. Okay, so we just leave it like that. If it can, yes. Well, I'll tell you what. If it can factor and you can cancel something out and you can simplify it, then you need to do it. If it factors but it doesn't cancel out, so it doesn't really like help by factoring it, you can just leave it like this. You hear what I just said? I'll say it again. If you can factor it, so for instance, if one of the factors was 2x plus 5, would you have to factor this? Yeah, because you got to cancel out the 2x plus 5. All right, if that happens. I don't know if they're going to give you one like that or not. I haven't done all the problems. I don't really know. But if it does factor and you can cancel something out after factoring it, just like we did that last lesson, then you need to factor it. Okay? Everybody with me on that? Yeah. All right, so we added with common denominators. So what do you think the next thing is going to be? We're going to add, let me see. Well, let's do a subtraction. Remember I said the same thing works with subtraction. Let's do a subtraction problem. So this is example 4, part B. This is a little bit tricky. So why do all my minuses have a little swirly thing at the end of it? I don't know. 3x plus 2 over x minus 3. Now, one thing's good about this. What's good about this? Common denominator, all right? So we write our fraction, and you just put your common denominator. All right, because they're both exactly the same thing. Now, you got to be careful with this. This isn't really that tricky. There are some that are a little bit tricky, okay? But on this one, it's not that bad. But you're not just subtracting a 3x. What are you subtracting? That whole entire numerator. Everybody see that? So it's going to be, I'll write it out. Okay, I'm not going to do this in my head. I'm going to write it out so you can see it. So you got your x, and you don't just put minus and then parentheses 3x plus 2. You got to distribute it through because you can simplify. So it's x minus what? 3x. Is it plus 2? It's minus 2. Why is it minus 2? Because that negative is being distributed through that parentheses. Ooh, now it's too cold in here, isn't it? It should shut off in a bit. Do we just leave it like this? No, you always simplify. So you can't simplify the bottom, so we'll keep that the same. What can you simplify up here? X minus 3x, which is negative 2x, and then minus 2. And that's all you can do. Technically, you could factor out a 2 from this if you wanted to, but does that help you? No, because it doesn't cancel out with anything. So you don't really need to factor the top. You can just keep it like this, and that's perfectly fine. All right? Now, we just did 2 examples with a common denominator, the same denominator. What do you think we're going to do now? We're going to do different denominators. So, I thought they had a AB example thingy. Where is that? Oh, here it is. Oh, I'm sorry. Before we do that, this is still a different denominator, but it's kind of, anyway, let's just look. Example 5. There's only one of these. Now, this is the one I was thinking of when I said this is really tricky. This one is the one that's a little bit tricky. Plus, oops, there it goes again. Why does it always do that? I don't know. There we go. Minus 5 over 3 minus x. Now, do we have common denominators here? It's close though, isn't it? Yeah, it's pretty close. Now, watch what we're going to do. I want to make it so that the denominators are the same. Now, here's a little trick. Everybody watching? Yep. This is the part. You got to concentrate. You got to watch. So, it would be really nice, and it's really close to x minus 3, but is this x minus 3? It's not, okay? So what I'm going to do is this. I am going to multiply this by a negative. Watch. And I'm going to multiply the top by a negative. Am I allowed to do that? Shh. Cameron, I don't need that. Just watch. Am I allowed to do what I just did right there, and why? Because it's a what? Yeah, it'll make it the same thing as this, but why am I allowed to just arbitrarily multiply the bottom by a negative and the top by a negative? Because put a 1 there. What's a negative 1 divided by a negative 1? It's a positive 1, isn't it? Isn't that what we just did right here, basically? We just multiplied the bottom by a negative 1 and the top by a negative 1. So really, in effect, all we did was just multiply by a positive 1 altogether. Did we change anything by multiplying it by a positive 1? We didn't, okay? We just made it look a little bit nicer for us, okay? It's going to give us a common denominator. That's the trick, all right? That's what we had to do. So let's write the first one. We'll keep that the same. I'm going to keep this a negative, but watch what I'm going to do. It's minus oh, my goodness. This was not a negative to begin with. Sorry, that was a positive to begin with. We could have still worked it out, but sorry, the example had a plus there. Sorry. Okay, yeah. We'll just do it with the plus. That's the way it is in here. Okay, so now what do we get here? So that was a plus, right, because of this. We got a negative 5 on top. So what do we get on the bottom now? We got to distribute that negative. We get a what? Negative 3, not minus x, but plus x. Now look at negative 3 plus x. Tell me something about this denominator and this denominator. They're exactly the same thing. Isn't negative 3 plus x the same as x minus 3? Sure, because you got a positive x and you got a negative 3. So what we did is we did a little trick to change this so it's the same denominator as this. Yeah, I'm just showing every step. Okay, you might have been able to just make this x minus 3 in your head if you wanted to. But I'm showing every step so people don't get lost. Okay, plus, I'm going to put a negative 5 right here. And over, now watch, I'm going to write this, instead of negative 3 plus x, I'm going to write this as x minus 3. See that? That's all I did on that step. If you can do from here to the next step in your head, that's perfectly fine. Now, check it out. Now I have a common denominator. So now I can just write the one denominator and then add up the top. So I got 2x plus negative 5. What's a plus and negative? Plus and negative is just a minus 5. And that's your answer right there. Okay, so what was the trick? The trick was this right here. I multiplied the bottom by a negative and the top by a negative. Why can I do that? Because if I multiply the bottom by a negative 1 and the top by a negative 1, it comes out to a positive 1. I can multiply anything by positive 1 and it doesn't change it. So I'm allowed to do that. All right, let's do the next one. What we're going to do now is this quarter of? Is that what this class is? 50. Oh, good. So we'll be able to do both of these. All right, let's do this. Remember that AB thing I did earlier? Let's do the same thing, except it's not going to be a common denominator. Everybody watching? Seems like I lost some of you. We haven't been going that long, have we? So let's take a look. Look right here. Can I just put a common denominator here? No, because they're two different denominators. So I got to make a common denominator. Remember that least common multiple stuff you did back in the day? So basically, if you have a situation like this, you can always find a common multiple or a common denominator just by multiplying the denominators together. That's not always the smallest or the least common, but you could always get a common denominator by doing that. Okay? Renee, you with me? Snap out of it. Shake it out. Shake it out. All right? So I got a B and a D. So how can I find a common denominator? Just multiply the two together. So B, D. I'm going to do two separate ones. I'll show you why. So that's my common denominator. But the thing is, what did I do to this in order to get to that? I multiply that by a what? A D. So what am I going to do here? I'm going to multiply that by a D. Now, we just talked about this. I can't just multiply the bottom by a D and leave it. Okay? I also have to multiply the top by a D. Why can I do that? Because D over D is 1. I can multiply anything by 1, can't I? And not change the value of it. So there we go. So what's going to be on top here? AD. You with me? This is pretty simple stuff, but we're going to translate this into stuff that's a little more complicated with those rational expressions, okay? With those things, with a lot of x's and numbers and pluses and all that kind of thing, all right? So this is basic, but the stuff that we're doing all goes back to this. What did we multiply this by in order to get to this? A B, correct? So I multiplied this by a B. So what do we do to the top? Multiply that by a B. We can do that because all we did was multiply by B over B, which is 1. I'm allowed to multiply by 1. So what do you have up here? Yeah, you could write it CB. I kind of like to put it in alphabetical order. It really doesn't make any difference. Wouldn't be wrong if you put CB. Now, look what I did. I changed it so I have a common denominator. Now I just use what we just finished talking about. I keep the denominator the same, and I add the numerators. You can't combine them, so you just leave it like that. Yes?
Since you did it says CB, since you did B cubed, so if it's a number, does it still matter?
No, because what's 3 times 5? What's that?
15.
Okay, what's 5 times 3?
Yeah, but what if it was a negative?
Doesn't matter. What's negative 3 times 5? It's negative 15. What's negative 5 times 3? It's negative 15. It doesn't matter. Okay? Everybody with me so far? All right, let's do a real one now. a real one. This is example 6. So example 6a. Hopefully we have time to do both of these. And this is x plus 4. So here's our example. So write it down. Plus x over x minus 2. All right, here it is. It says to add. All right. That's what the problem tells you to do. So what do we need to do? We need to find a what? Common denominator. How can you find a common denominator? You can just do what to these? Just multiply them together, right? That's how you can always find a common denominator, just by multiplying the two different denominators together. Okay? So let's do that. So I'm going to put x plus 4 times x minus 2. The reason I put them in parentheses is because I'm going to multiply them together, and that's how we show multiplication. And that's going to be the common denominator here as well. X plus 4, x minus 2. Tell me if you can see this yellow. Oops. Can you see that yellow okay?
Yeah.
All right, good. So now watch. What did you do to this in order to get to that? I didn't do anything at the top. Answer this question. Right. You multiplied this by x minus 2 to get to this, right? So you multiplied the bottom by x plus 2. So that means you have to do what? Do the same to the top. And the reason is, it's not because whatever you do to the bottom, you do to the top. That's not the rule, okay? The rule is, if you multiply the bottom by something and the top by the same thing, you're multiplying by a 1. We can multiply anything by 1. All right? So what are you going to get over here now? You're going to get, it's x minus 2. My bad. Sorry about that. Thank you. Let me see if I can erase that part. There we go. And then, yep, sorry. I just messed up. All right, so what are we going to have up here? We're going to have x minus 2 and x minus 3. Oops, x minus 3. Okay? Let's do this one a little faster. What do we do to this to get to this? Multiply by x plus 4. And so what do we do to this? Multiply that by x plus 4. So you got x times x plus 4. Okay? Now, we might have some things to... now, on the denominator, you do not have to multiply the denominator out. You can just keep it. Keep it in factored form, as they say. X plus 4, x minus 2. But on the top, you need to multiply it out. All right? So this thing right here is a distributive property. It's a FOIL method, isn't it? So let's do FOIL method on that. So first outside, inside, last. Let's do it real quick here. So I've got an x squared. Outside, can we do this in our head? The outside and inside? The outside is negative 3x. The inside is negative 2x. It's negative 5x. And then the last is plus 6. All right, that's old stuff. I don't need to go over that. Plus, let's distribute this through here. So what do I get? I got an x squared plus 4x. We always have to simplify. Keep the bottom the same. The bottom can stay in factored form. It's perfectly fine the way it is.
So we never have to put the bottom back together?
Right. You don't have to multiply out the bottom. Just keep the bottom in factored form. But the top, see, now that I did this, now you got some stuff you can add together, don't you? So what do I have? Let's do the x squareds first. I got an x squared plus an x squared, which gives me 2x squared. So I'm done with that one. What else do we have? Let's do the x's next. I got a negative 5x plus a 4x gives me negative x. I'm done with that one. What do I have left? Plus 6. I'm done.
That was so fast.
Make sense? There is another example, example 6b, but we don't have enough time to go over it. So you go over it yourself. You can look at it in the book. It's not much different than what we just did. So let me give you your assignment. Write this. Oops, there we go again. Section R.7, Part 2. Make sure you write that at the top of your paper. Here It's pages 69 and 70. And it's 35 to 51. It's not that many because you're only doing the odds. There it is, right there. That's in RenWeb. I did change it because I had to modify it a little bit because we didn't get as much done on Monday as I wanted to, or Wednesday, whatever day it was. So I've modified RenWeb a little bit. If you looked at it earlier in the week, somehow I doubt anybody did, but there you go. All right, that's all we got.